All right, day 6, medians and altitudes. Not attitudes, altitudes. So we're going to identify and use medians and altitudes. All right, what is a median? It is a segment from a vertex to the midpoint of the opposite side. Now think about it. When you hear the word median, all right, where's the median on the highway? Isn't the median in the middle of the road? Right? So therefore, think about that when you're looking for the midpoint. Okay. So what are we going to do on this figure to draw midpoints? Medians. Well, we need to mark the midpoints on each one. And again, we're just kind of estimating right here. And we've done this already with mid-segments. And if we're doing mid-segments, we connect all these three and make a little triangle inside of it. Similar concept. We're going to draw, and we want to use a straight edge for this. You want to draw from the vertex, a corner, to that point. That is a median. This is a median. That is a median right there. So we need to mark the midpoints. So it says BZ is a median. Well, we know it's coming from this vertex right here. That's not what's supposed to be happening. There we go. Okay? So if it's a median from B, that means we're going to the midpoint of the opposite side, like so. And you can use a ruler to measure and find the exact point, or you can estimate. Okay? Just like that. Oh, and then don't forget to mark Z. Now, what's an altitude? It's a perpendicular line segment from the vertex to the line that contains the opposite side. All right? So, we're going to form a right angle. So, on an acute triangle, it's going to drop down like so and form a right angle. On a right triangle, this leg right here is the altitude. And then this one's interesting on an obtuse triangle. When you say the opposite side, it actually drops down like so. And what we do is we draw a dotted line and then do that. So the altitude is actually outside of the obtuse triangle. All right, BZ is an altitude. Oh, my mind was a little wonky right there. So we're doing the same triangle, but we're doing an altitude this time. So from BZ, we're just going to drop a line straight down and form a right angle and mark this Z. So notice, you don't have to draw this, but remember, we drew the median like that. Okay? Both coming from B, but two different lines. If they were the same line, it would be a perpendicular bisector, which we've already talked about. Okay, a little bit of review here now. Name an angle bisector. Well, we need to find an angle that's split into two equal parts. F has no line coming from it. D, you can tell that this angle is a different size from that angle. But look at B. See those two arc marks the same? That means angle B has been split into two equal pieces. So the angle bisector is line segment BE. Name an altitude. As soon as you hear altitude, you've got to look for a right angle. So where do we have a right angle? We have one right here and right here. But remember, an altitude must come from a vertex. The one at C is AC, or actually CA, technically, it's a red. not coming from a vertex. So that is a perpendicular bisector. I say that because of the two hash marks here. It's a perpendicular bisector, but it is not an altitude. Look at G, right angle, and it goes to D. So DG, line segment DG, is an altitude. Perpendicular bisector, I've already hinted at. That would be, now careful with this one, we have to write it like this. It's starting at C, going towards A. Or I could say AC, but remember, the arrow has to go from the C to the A, because it is a ray, not a segment. And a median. Remember, a median must come from a vertex. All right? So from B, well, let's check D. D goes to G. That is clearly not a bisector. That green is way longer than blue. All right? So it is not from D. There's nothing coming from F, so let's look at B. B has a line right here, and it splits this side into two equal pieces. That makes it a median. So line segment BE is a median. It comes from a vertex, and it splits the opposite side into two. Okay, YOU. Up is the median. So whatever you want to do. People usually like to draw medians from the top. So if that's the case, you might want to put U here and Y, no, it doesn't matter. You don't have to. Just some people like to prefer to have the vertex being used at the top. You do what you want. So UP is the median. That means it goes from here to there. That's P. YP is 3x minus 6. And YO is 4x plus 10. Be careful. YO is this entire thing. So what is PO? 3x minus 6. We've done this before, just without the terminology of median. So remember, we need two of these to equal the whole right here. So that's 6x minus 12 equals 4x plus 10. I like to keep my x's positive, so I'm going to subtract 4x. I'm going to move the 12 over, so I'm going to add 12 and get 2x equals 22. When I divide by 2, I get x is 11. But that's not what it wants me to find only. It also wants yp and yo. So if I plug in yp right here, 11 right there, yp is 3 times 11, which is 33, minus 6 is 27. Now yo is the entire thing, so I need to double that, 27, to get 54. All right, ACE, CRE is the median. I'm going to do that now to show you. Let's say I put ACE. That's okay. CR is the median, which means I need to find the midpoint of this side. Let's say that's it right there. All right, so I make CR here. It does not have to be the top point. Some people prefer it that way. That means this piece and this piece are equal. RE is 3x plus 20. That's the part. And it says AR is 11x minus 5. I missed that part. Sorry. Well, those are both parts, and they're both equal parts. So 11x minus 5 equals 3x plus 20. Again, keeping my x's positive, I'm going to subtract 3x. Now give me 8x minus 5 equals 20. I'm going to add 5 and get 8x equals 25. So if I divide by 8, I get x equals 25 over 8. Now, if you type this into the calculator, because it's going to be a difficult thing to plug this into 11x and 3x, because 8 on the bottom is not common with 11 or 3, we can change this into a decimal. So if you divide 25 divided by 8, you actually get a pretty decent decimal, 3.125. Don't round it, it's only 3 numbers. Now, if you, all you do here now is type in your calculator, like 3 times 3.125 minus, plus 20. And when you do that, you will find out that it is 29.375. And they're both equal, so RE and AR are 29.375. So it's a decimal, but it's kind of a nice decimal. It's easy to work with. All right, example 3, FOR. IF is the altitude. Now, with altitudes, it is usually easier if you have it at the top. It's just easier for most people to draw that straight line down. So I'm going to put my F up here, and then O here and R here. When I drop the line straight down, using a straight edge, FI, right, is my 90-degree angle. Put the 90-degree angle in there. Now it says FIO, F to the I to the O. We know it's 90. So it says find X and the measure of FIO. Well, we already know FIO. That's easy. FIO, measure of that equals 90. So it has to be, it's an altitude. So we're done there. We still have to find X. But all we do there is 5x minus 15 equals 90. So we're going to add 15, 5x equals 105. Then divide by 5, that's right, the word is, x is equal to, 5 goes into 10 two times, 5 one time, 21. So x is 21, and FIO is 90. Easy enough. All right, PAR, PT. This one, same idea. Going up is also easier. So PAR, going to draw my straight line from this corner, this vertex, to the opposite side, 90 degrees. Scoot that over a little bit. Always put your 90-degree mark in. Put your T. Now it says PTA. Well, that's P to the T to the A. Again, it's kind of silly, but we know that already. The measure of angle PTA is 90. We're halfway there. Now what we do, since this is equal to 9x, and you can do this in your head, I'm sure, 9x equals 90. So what's x? 10. And that's it. We're done.